Yes, I can hear you.
Yes. Okay, it's your time.
Okay.
Enjoy your talk. Okay.
Okay.
Perfect.
So I have added some captions in Italian just for extra help. Basically, going to talk about tension for double-sided paintings and technical solutions that we have been using over last almost 20 years. So, all masters' paintings were nailed on inexpansible strainers, and as you can see, there was no, as everybody knows, there was no possibility of changing, adjusting tension over time. This is mostly because animal gelatin glues and canvas and the wood of the strainer sort of kept the painting as a closed system, which was always in equilibrium with the environment. And this meant that with medium to low RH, tension was often enough until damages occurred. Corner expansion stretchers, as we call them now, are most likely restorers stretchers. So they were invented during the conservation era and appeared in mid 18th century. There are documents stating that they were invented around 1754, something like that. They are most suitable for line paintings because they cause stress to corner areas, as Marion Mecklenburg showed us many years ago. The expansion of the stretcher causes deformation of the canvas. And this is an engineering simulation of stresses. The deformation is increased for better visualization, but you can see the stress is concentrated in the corner area, whilst there is very little tension in the center. This is a very, very interesting example, and it's an elastic expansion stretcher which was invented, patented in the States in mid-19th century. And basically, you see that here someone started thinking of springs instead of corner wedges. And but springs are too hard, and they cannot be compressed by the painting when it contracts. So basically, they behave as a constant expansion, the mechanism, which eventually tears the canvas. Though corner expansion was meant with the best intentions, because it was meant to have and keep the painting flat and beautiful. But it looks very much like a Middle Ages torture system. Damages caused by rigid constraints and corner expansion are in all conservators' daily experience. It is less clear that paintings need to be free to move. And let's have a look at this double-sided canvas mounted without stretcher. Actually, it's mounted inside its frame, so it's never had a stretcher. And the work has been done in collaboration with Sandrine Jadot-Pivet, and basically the painting has been hanged with springs in the frame, and it is free to move. Moves inwards and when it becomes dry, and outwards when it's humid, and the free painting is a happy painting. It doesn't have any problem anymore. So long and soft springs follow movements in all directions. And here we have a very low tension, which is 6 kilograms per meter. It's very important that springs are soft and long, because if they're soft, the painting is always able to win over the springs. And if they are long, there is a very small change in force with dimensional changes in the painting. But how do we choose tension? Is it only a subjective matter? With the research we've done a few years ago, we have seen that increasing tension on stretcher here, the deflection due to the pressure of the hand decreases, of course. So more tension, the stiffer the painting becomes. But if you go after a certain limit, this changes less and less. So basically, all tension exceeding that amount of tension is not useful for keeping the painting flat. So tension counteracts forces and weight of the painting. The weight is a key word. And using elastic tension since 1992, we have this, we have set numbers for different kind of artifacts or paintings. And so we have published most of them, and we have a very long list of 10 stretched paintings. Let's have a look at this before I hand the stage to my business partner. This is a double-sided silken banner painted by Sodoma in early 16th century. And the work has been done in collaboration with Daniele Rossi and Luciano Sostegni of Opificio delle Pietrature in Florence. And it's relatively big. It's something like 180 tall. And it's in Basilica di San Domenico in an uncontrolled environment. And soft and long springs keep it in gentle tension with 8 kilos per meter. And it's a lined silk. It's important to state this, otherwise it would have been impossible to give it such a strong tension, though it's very gentle. And there is no change, no problem since 2007. I leave the stage to my business partner, Carlo Serino.
Here I am. Good afternoon. I'm Carlo Serino. I'm okay. I'm very happy to be here, and I will show you some applications of our mounting system. Here you can see a double-sided painting from Città di Castello, which had an old double gilded frame on the two faces. Our tensioning devices are very thin, they take up little space, and they can be easily adapted to different technical solutions. They make it possible for us to reuse original or old frames. In this case, the tensioning system has been inserted between the two frames on a steel shell. I would like to point out that this is a work of some years ago. Today, we would perhaps do it in a different way. Probably we would use composite materials. What we love about composite materials is their lightness and stiffness and versatility. For example, this is the last support we have made for a double-sided painting from Padova. And for this painting, we wanted something really light. The tensioning system is the usual with long and soft springs. And here you can see the pulleys and the metal wire to connect springs and painting. And there is a steel bar inserting in the strip lining, creating tension all over the painting. The tensioning system is the same, but the structure is different. Here is a section of the new support. There are two composite shells. They have a light sandwich structure with two carbon and epoxy skins and a PET foam core. The wooden cover gives the frames a natural and traditional look. In some cases, lightness is a necessity. Here you can see a double-sided painting by Kokoska. The faces of the painting have inverted orientation, and thanks to reduced weight of the composite structure, a single person can switch from one face to the other in a very safe way. However, the most convenient solution is to use aluminum. It's light, very cheap, and usually stiff enough to avoid crossbars, even with larger paintings. We really love this mounting system because it's very effective, and it can be very gentle and soft, and we often use it also for one-sided paintings. For example, we use this mounting system for the paintings by Tintoretto of the Sala dell'Albergo at the Scuola Grande di San Rocco in Venice. And here is another example, a big painting by Giacomo Balla. And here is a sketch by Cesare Nebbia for the Cathedral of Orvieto. Now we are working on possible improvements, and our first target is to reduce friction even more. For example, by mounting the pulleys on ball bearings and using bronze bushings on the sliding bars. Thank you for your attention.
Thank you so much for your talk and for being here.
So this raises the question that was initiated by Antonio, raised last week, and his idea of maximum useful tension. Is there a safe tension? And he found a region in the area of 2 to 2.5 newtons per centimeter as a region where it didn't seem to make much improvement when you kept pulling on the stretcher bars in terms of how tight the painting would get when judged by pushing on it a bit. So I went looking to see last week, I went looking to see if there was a calculation or published article online, as an engineer would do. You don't want to do the research in the algebra if it's already been done. And these so-called membranes, thin things that are stretched, are well researched in the mechanical literature. And I did find, I'm moving here to a scale with the 0 points, and this is Antonio's suggested curve with 0 in place. I found this article by NASA engineer on deflection of stretch membrane under pressure. And there are the equations. And fortunately, you have to solve the equation above, and Excel is quite good at solving those sorts of equations. So I took the elasticity or the stiffness determination for 1 minute. And so if we're wondering how much a stretcher will do, and that blue line is appearing unwanted. I want you to focus on the green line. One thing about Excel is when you migrate into a PowerPoint, it doesn't always behave. Anyway, the green line is the deflection of a 1 meter painting if you just calculate how much it deflects for its own weight. So we get a curve. The green line curve is similar in shape to Antonio's curve. except rather than adding a weight in the middle or pushing in the middle, as Antonio did, what I've done here is calculate, suppose that painting was horizontal, just under gravity, how much would it sag in the middle? And you can see here that it begins at around 7 millimeters and drops quite quickly. Now, I point out, I also calculated what that is in terms of wind. So if you're carrying this object vertically, and there was a discussion of wind loads or just flapping in a procession, one degree of gravity or the weight, if you put the thing vertically, that is equivalent to a 15 kilometer per hour wind, which according to weather standards is considered a light breeze. So a very light breeze, which might even be possible with a ventilation system in a museum, will cause this kind of deflection as the tension changes. The yellow line shows, the green line, I'm sorry, the green line shows what happens in 100 years. It comes back down to around 2 to 3 millimeters deflection quite quickly. So what I've done is say how much tension is going to drop the deflection by at least half. And it turns out to be very close to the 2 newtons per centimeter that Antonio had suggested. If we look at 5 times the weight or very strong winds, you really, as you can tell by common sense, you might need to have a lot more tension in the object. By the way, 5 times the weight is equal to a 32 kilometer per hour wind, which is considered a fresh breeze. So nothing particularly violent, but you would notice it. Forgot to take that slide out. So I just wanted to generalize that in here, around 2 to 3 newtons per centimeter, we have a reasonable amount of safe tension. And as I calculated earlier, that would probably give us maybe a 1 millimeter stretch of the painting in 100 years.
And finally, I'd like to talk about some thoughts about spring-loaded stretchers. The real question I had while listening to talks on Wednesday, how much force is being applied by the springs to the banner? And Antonio Iaccarino was the most gracious to send me his talk that had actual measured loading data near 50% relative humidity. And it was in the units of kilograms per meter of the painting edge, which I converted into newtons per centimeter of the painting edge. And below are the load ranges that are both for lined and unlined paintings. And this is from his talk on Wednesday. And here's the actual data down here at the bottom. For an unlined painting, he said that the spring loading was approximately 8 newtons per centimeter to about 1.6 newtons per centimeter. And for the line paintings, it was about 1.3 to 2.3 newtons per centimeters. Now, I'd like to compare that to some of the information we've had. And this is one of the most remarkable things that has come out from all of this for me. When I looked at Antonio's data and compared it to the plots that I had, I found that Antonio's data fell really in a very self-range right here. Now, this is remarkable because Antonio was able, using intuitive loading, and we were able to compare it to actual data. And the fact that a conservator has the ability to do that is pretty remarkable. And I think that's to be a real compliment to the conservation field in general. Now, I'd like to go further with this and say, well, let's see what happens when he does a line painting. And look at this, the same thing happened. Now, remember, I showed that a banner and a line painting actually behave very similarly. And again, here's Antonio's data for the loading he puts on his paint. Again, it's a very safe region. Well, this encourages me a lot. And the reason I'm saying this is, well, if we can get accurate measurements of what a painting is actually doing, then we have a very strong insight as to what the loading ought to be for preserving those paintings. Now, let me tell you what the hazard might be. Let's suppose we increase the relative humidity. That means go over here. If you'll notice, the loads on the painting get extremely strong. So this spring might be pulling this painting apart. So the question is, what is the solution? Antonio suggested that we use very low spring constants in long springs. Now, what that means is that it's going to take a lot of spring relaxation to accommodate these large loads, these small loads. And I think that's important. It suggests that as the humidity drops and the painting gets weaker, the spring definitely wants to elongate, but it's going to elongate with very low loading. And the real trick here is that what if we put an even lower load on this? Well, that can lower this whole picture. It'll also mean that at high humidity, the painting is going to go slack. So what you want that spring to do is to take the slackness out of the painting. So I think that further development of that spring and loading tension is going to be very insightful.